So the spherical coordinate system, it depends on the one radius and a theta and a phi, and the theta is the angle between the z axis and the radius of the sphere, and the phi is the angle between the z axis. As we know, it's a rectangle, so that will be equal to each other. So z and x is the phi. Angle between these two is phi. So that is a spherical coordinate system, the 3-point representation. If it is a sphere, and this is a point that we have to define here, that we have to find out this point. First of all, we have to draw a line between the point and the origin O and the point. That's an origin O. So that is the radius of the sphere. Then it's a coordinate system. So if it is x, y, z, it's an x, y, and the z. The theta angle is the angle between the r and z, theta, that you can see, and phi will be, if it is a projection of a line, this line and this line will be created from the origin, this angle is phi. So that is the spherical coordinate system. So after all, we have finished the three coordinate systems, and we have to convert the coordinate system with each other. Just like if you know the rectangular coordinate system, you have to know how you can convert it to cylindrical, and vice versa. After, if you know the cylindrical coordinate system, how you can convert it to spherical coordinate system, and vice versa. So that's the thing overall. So now here you can see, if it is a coordinate system, Cartesian coordinate system xyz, you have to know the convert between these two, spherical coordinate system and cylindrical coordinate system, and both cylindrical and spherical coordinate system. If you know these things, so it will be easy for you to the next part of calculations. And there are some rules that how you could change. Here is the two important coordinates for coordinate system transformations. That is the coordinate system transformation from the Cartesian to cylindrical coordinate system transformation. That means here you can see, from xyz to r theta phi. The r in some of the books are written as rho, so don't panic while you see this kind of notations. R and rho are quite similar. So x y z to r theta phi, that r theta phi means that is Cartesian to spherical theta phi, and that is in here we have used that from Cartesian to cylindrical, that will be r phi z, I would guess, r phi z, and from r or rho phi z to the xyz. There are two transformations. First of all is from Cartesian to cylindrical. If you know x and y, x, y and z of a coordinate system, you could transfer x, y, z to cylindrical by this equation. Rho is equal to root over x square plus y square, phi is equal to tan inverse y by x, z is equal to z. After that, if it is an x, y and z, if you want to find out x, y, z, you know rho phi z or r phi z, you can now convert it from here. X is equal to r cos phi, y is equal to r sin phi or rho sin phi, and z is equal to z. How that begins, just look at it. If it is a point of if it is the origin, that is x, that is y, and that is z. So if it is a point P in Cartesian coordinate system, that will be x y z. But in a cylindrical coordinate system, how that will become, we have to first know it. Just look here, just draw a cylinder with respect to it, and then find it out. Okay, r or rho is down to here, from 0 to the last end point of the circle of a cylinder, this point. So you can now understand this clearly. It's quite like this, that is the coordinate systems x, y, and z. And if I draw a sphere here, sorry, a cylinder here, now it is quite understandable for you. From this point to that is r or rho. So rho, that is x, and that is y. And if you draw these 2 points and calculate it as apply the Pythagoras theorem, we can get rho is equal to root over x square plus y square, as it is a orthogonal triangle or rectangular triangle. Phi is between the r and x, so that will be tan inverse y by x. Okay, and the z is equal to z. In both coordinate systems, z is common. Then you can get similarly the another point, that if you find out x, that is rho, just look at the point in that portion like this. That is x, and that is y, and that is the rho. If you look from here upside down, if you look from here upside down, so you can find out that rho is equal rho, and that is x axis, that is y axis, as we know. In that vector division, in x axis we can write rho cos phi. If we divide a vector in x axis, we always get cosine term, and in y part you will get sinusoidal part, rho sine phi, and z is equal to z. That's all for the coordinate system transformation, Cartesian to cylindrical.